Hey guys, hi, welcome to the session. I hope you guys are doing well and yeah, how you have enjoyed your holiday. So, and am I audible to you? So, just please inform me whether I am audible you or not. Okay, so I guess I'm clear. Yeah, so this is Padma Tejaswi and I have done my masters in chemical engineering from NIT Rourkela. So today's I'm going to take a session on previous year questions of thermodynamics. Okay, so yeah, I hope you guys are excited. So thermodynamics is like a very important topic for both chemical engineering and mechanical engineering students. Okay, so yeah, mechanical engineering students can also attend this session because when, as far as I know, the topics that we are having, both of us are having like few topics are same. Okay, so if you find that we are having the same topics, then you can attend the session. And yeah, if you have any doubts, please post your doubts over here so that I will be able to answer you people. Okay, yeah, so let's start the session. Okay, so we have given that molar residual Gibbs free energies, GR. Okay, so and molar residual volume VR are related as GR by RT is equal to integral of 0 to P VR by RT dP. Okay, find GR at T is equal to 27 degrees centigrade and P is equal to 0.2 megapascals. Okay. Next, the gas may be assumed to follow the virial equation of state Z is equal to 1 plus Bp by RT, where B value is given and the value of universal gas constant R is also given. So, from this, what we have to calculate? We have to calculate what is the value of GR. Okay, so this is an interesting question. So this is from basically this question is from solution thermodynamics. Okay, yeah. Um, okay, so now what is GR? These are residual properties. Means for residual property means what do you mean by residual? So residual property is nothing but the relation with the difference of a property for a real gas. I mean when it is deviated from ideal condition. So property of Okay, so molar property in real condition minus molar property in ideal gas conditions. Okay, so by using this value, we will be able to know till what extent this a property is deviated. Okay, yeah, and we have molar residual volume also. So these are related with GR by RT is equal to integral 0 to P VR by RT dP. Okay, so this is also equal to ln phi, right? So what is phi? It is fugacity coefficient. Okay, so gr by rt is equal to ln phi, which is equal to integral of 0 to p vr by rt dp. Okay, so we can, so let us solve this question. What we have the given data? We have given data as temperature is equal to 27 degrees centigrade. So convert it into Kelvin, which is 273 plus 27, which gives 300 Kelvin. Okay, and we have pressure as 0.2 megapascals, which means 0.2 into 10 power 6 pascals, right? Yeah. So we have this data, and yeah, B value is also given. This is virial coefficient, right? So B is equal to minus 10 power minus 4 meter cube per mole, and R is equal to 8.314 joules per mole Kelvin, right? So we have this data, and yeah, here we have to use this Z is equal to 1 plus Bp by RT. So we have to use this Z is equal to 1 plus BPRT in the equation which is relating GR by RT and VR by RT, right? So what is residual volume? As I said, residual property means it is the difference between real condition and ideal condition. So VR is equal to V minus V ideal gas. So we can write it as V minus. So for ideal gas equation, PV is equal to RT, right? So V of ideal gas condition is equal to RT by P. And at the same time, if it is in real gas condition, then V is equal to ZRT by P, right? So from this we have ZRT by P minus RT by P, which is equal to Z minus 1 into RT by P, right? So residual volume can be written as Z minus into RT by P. So, and as they have given Z is equal to 1 plus BP by RT, so what will be Z minus 1? It is BP by RT. So in place of VR, we can keep it as, in place of Z minus 1, we can substitute BP by RT into RT by P, right? So we can write this as RT by P can be cancelled, which is VR will be equal to B, right? So basically VR is equal to P, and yeah. Okay. So what we got? VR is equal to B, right? So now it is simple. So from now we have all the data, right? So GR by RT is equal to integral of 0 to P, which is VR by RT dP, right? So this VR is equal to B. That means GR is equal to integral of 0 to P B by RT dP, right? Yeah. So this is what the equation. So from this, as if you integrate this equation, what you will be getting? BP by RT, GR by RT is equal to BP by RT, right? So from this we have GR is equal to B into P. So what is the value of B? We have B value as minus 10 power minus 4. So GR is equal to minus of 10 power minus 4 into meter cube per mole. Meters yeah, what is pressure? It is 0.2 megapascals, right? So 0.2 into 10 power 6. So from this you will have 0.2 minus of 0.2 into 10 power 2, which means minus 20. So residual Gibbs free energy is nothing but minus 20 joules per mole. Okay. So is that clear? I hope you guys are clear with this. So the main important thing that we should know here is how to substitute and where to substitute. Okay. Each and every point they have given. They have given Z is equal to 1 plus dP by RT, and they have given the relation between GR by RT and VR by RT also. So we have all the temperature, pressure and virial coefficient, and universal gas constant value is also given, right? And moreover, this is not a numerical, right? So this is a choice, this is not a blank question, right? So we have options also. And yeah, so if you know that residual property means it is the difference between real gas condition and ideal gas condition, and what is real volume, and how it is related with temperature and pressure, and how this ideal gas equation is related with temperature and pressure. If you know this point, and if you know that VR is equal to volume of real minus volume of ideal, then you will be able to answer this question very easily. Okay. Yeah. So I hope you guys are clear, and yeah, if you have any doubts, please post your doubts over here, so that I will be able to answer your queries. And yeah, if you're having any doubts, I am happy to clear your doubts. Okay. Yeah. So let's get into the next question. Yes. So what do we have? This is one question and this is another question. Okay. So yeah. Which of the following can change if only the catalyst is changed for a reaction system? Okay, first one is enthalpy of the reaction, second one is activation energy, and third one is free energy of the reaction, and fourth one is equilibrium constant. So I guess by this time you have know the answer. You guys just know the answer. So if you are increasing, if you are using a catalyst, it will increase the, it will change the activation energy, right? Means why catalyst is used? It is used to, it is used to reduce the time taken for the reaction. Means it will speeds up the reaction. So it just enhances the rate at which the reaction is happening, right? So means by decreasing, by changing this activation energy, the reaction temperature, the time at which the reaction completes or the reaction initiates will be varied. Okay, so option B is the correct answer. Yeah, and next question. So an ideal gas is initially at a pressure of 0.1 megapascals and a total volume of 2 meters cube. Okay, so they have given the graph also. So this is a graph between pressure and volume, and here pressure is changing and volume is also changing, and here volume is changing but pressure is not changed, right? Yeah. So we are having an initial volume of 0.1 megapascals, means P1 is equal to 0.1 megapascals, and total volume of the system is 2 meters cube. Okay, so it is first compressed to 1 megapascal. So when it is going from first state to second state, so as it is going from first state to second state, it is compressed till 1 megapascal. So when we are compressing, what happens? The pressure exerted by the molecules or gas molecules increases, right? Yeah. So pressure P2 is equal to 1 megapascals by a reversible adiabatic process. So what do you mean by reversible adiabatic process? Means adiabatic means there is no heat absorbed or no heat produced by the system, which means Q is equal to 0 in second step, right? And and then cooled at constant pressure. So from 2 to 3 they are maintaining a constant pressure. So P3 is equal to 1 megapascals and it is cooled, means temperature is decreased, right, to a final volume of 0.2 meters cube. So the final volume is, which means V3 is equal to 0.2 meters cube. So this is the data from the question, and they require the total work done on the gas for the entire process up to 1 decimal place is, see they have mentioned till what decimals they require the answer, right? So give your answer according to that decimals only. Okay, yeah, and what is the data, extra data that they have given? So they have given information about R value and heat capacity at constant pressure, which is Cp. Okay, so they have given information about Cp also. So we need work done from 1 to 2 and work done from 2 to 3, right? So yeah, they have given a hint also. So in the hint, from first to 2 it is a reversible adiabatic process, and 2 to 3 it is a reversible isobaric process, right? So yeah, so that is what they have mentioned, right? So it is first compressed to 1 megapascals by reversible adiabatic process. Means whatever this, the initial volume and pressure they have given. So this is compressed and pressure is increased, and in this process is happening due when maintaining Q is equal to 0, right? And next process is constant pressure, which is isobaric process, right? So I guess you are clear with the question. See, if you don't understand the question, read one more time, and again if you don't understand the question, read again. Okay, so at least try to read the question for 1 minute, okay, or like 2 minutes also. But if still, if still by reading the question for 2 to 3 times, if you don't understand what it is, then just skip to another question. Okay, yeah. So what we have data. So let us know the data again. We have P1 is equal to 0.1 megapascals and V1 is equal to, so what is the volume? 2 meters cube. So this P1 means 10 power 5 pascals, right? Because 0.1 into 10 power 6 will be 10 power 5. So V1 is 2 meter cube and yeah, P2 is equal to 10 power 6 pascals because 1 megapascal, right? And V2 we don't know, and we have V3 which is equal to 0.2 meter cube and Cp value is given as 2.5 R and R value is also given, right? Yeah, and according to the graph we have this 1 to 2, 2 to 3, so P and V. So 1 to 2 is an adiabatic process, which means Q is equal to 0. So when Q is equal to 0, how this first law of thermodynamics changes? So according to the first law of thermodynamics, we have delta U is equal to Q plus W, right? So from this we have work done is equal to delta U. So you can write either this or you can also write using minus PDV. So if you write using that, we give P1 V1 minus P2 V2 by gamma minus 1, right? So for an adiabatic process, the answer is this. Okay, yeah, P1 V1 minus P2 V2 by gamma minus 1. So in this, for calculating work done in 1 to 2 step, do we have all the data? We have P1, we have P2 and V1 is given, but we don't know what is V2. So how we will calculate volume in the second step? How will calculate? So basically we have PV power gamma is equal to constant in an adiabatic process, right? So from this V2 by V1 is equal to P1 by P2 whole power 1 by gamma, right? From this V2 is equal to V1 into, what is P1 by P2? It is 0. Or else 10 power 5 by 10 power 6 power 1 by, so what is gamma? It is equal to Cp by Cv, right? So we have Cp and what is Cv? So from R, we have a relation regarding Cp and Cv with R. So Cp minus Cv is equal to R. From the Cv is equal to Cp minus R, which means 2.5 minus 1 into R. So from this we have Cv is equal to 1.5 into R, right? So use this values. So 2.5 by 1.5. So basically it is 5 by 3. Gamma value is 5 by 3. So 1 by gamma means 1 by 5 by 3, right? So V2 is equal to, volume is 2 into 10 power minus 1 into 3 by 5, right? So if you do the calculations, you will be getting volume V2 as 0.50 meters cube. Okay. So are you clear till now? So if you have any doubts, please post your doubts over here. Okay. Yeah. So next one is just a minute. Okay. Yeah. So now from what we got, V2 as 0.5 meters cube, right? Yeah. So from this equation, from this, we can calculate what is the work done. So work done is equal to P2 V2 minus P1 V1 by gamma minus 1. So this will be P2 is 10 power 6 into 0.5 minus 10 power 5 into V1 is V1 is equal to 2, right? Okay, so this is P1 V1 minus P2 V2. So by gamma minus 1. The gamma minus 1 is 5 by 3 minus 1. So from this, we will get in the work done in the first step as somewhere around minus 450 kilojoules. Okay, so please do the calculations again. If you have any doubts or if I have missed any sign convention, please do mention and give the answer also. Okay, so for the first process we have calculated, done in the first step, right? So what we have now, so we have to calculate work done in the second process, which is going from 2 to 3, right? And this step is a reversible isobaric process. So what do you mean by reversible isobaric process? What is reversible isobaric process? Isobaric means pressure is maintained as constant, right? So yeah, so for the second step we have isobaric, which means P is equal to constant. So for this process, work can be given as minus P into V2 minus V1, or you can also write it as P into V1 minus V2. But as this step is going from 2 to 3, we have, yeah, very good Dhananjay. Isobaric means pressure is maintained as constant. So we get P2 into V2 minus V3. So what is pressure 2 in the, what is P2? We have P2 as 10 power 6 10 power 6 pascals. So we have 10 power 6 into V2, we got 0.5 minus V3 is point 0.2. So V3 is 0.2, which gives 0.3 into 10 power 6 joules. Okay. So this is the answer, and you can write it as 300 kilojoules. Okay. So work done in the second step from 2 to 3 is 300 kilojoules. So what we need from the question? We need work done overall. Means when it is changing, going from 1 to 2 to 2 to 3, what is the overall work? So it will be the summation of work happening when it is going from first state to second state, and work done from second state to third state, right? So work done in the first step, what we got? Minus 450 kilojoules. So minus 450 plus 300, which gives minus 150 kilojoules. Okay. So the answer is, which is having 150 kilojoules. Okay. Yeah. So I guess you are clear. So if you have any doubts, please post your doubts over here, right? Yeah. So next question. A binary liquid mixture is in equilibrium with its vapor at a temperature of T is equal to 300 Kelvin. Okay. So we are having a binary liquid mixture. So binary liquid mixture means they are of two components, right? And it is in liquid, the liquid is in equilibrium with vapor state at a temperature of 300 Kelvin. Okay. So next one is the liquid mole fraction X1 of species 1 is 0.4. So X1 value we have as 0.4, and molar excess Gibbs free energy. So we have GE value as 200 joules per mole. Okay. So next one, the value of the universal gas constant is R. R is equal to 8.314 joules per mole Kelvin. Okay. So gamma 1 denotes the liquid phase activity coefficient of species I, and they have given that ln gamma 1 is equal to 0.09, and then the value of ln gamma 2 up to 2 digits after the decimal point is. So this is a very easy question. Let us know the data. Let us group up the data. What we have, GE is equal to 200 joules per mole, and mole fraction X1 is equal to 0.4, and temperature is equal to 300 Kelvin, right? And we also have value of ln gamma 1 as 0.09. So they need what is ln gamma 2, right? So See, when you read the question from thermodynamics or any topic, so first of all, put the given data, right? All the terms what they have given and what they are, what they require. Okay. So from this, what you get to know. So we should generate an equation which will relate GE with ln gamma 1 and ln gamma 2 and x1 and x2. Okay. So what is the equation? GE by RT is equal to x1 ln gamma 1 plus x2 ln gamma 2. Okay. So this is the equation that will relate all the given terms, right? So we have Gibbs excess Gibbs free energy, mole fraction, ln gamma 1, ln gamma 2 and x2. So from this we get 200 by R value is 8.314 joules per mole Kelvin, and temperature is given as 300 Kelvin, which is equal to x1 is zero point 0.4 into ln gamma 1 is 0.09 and x2. So basically the sum of mole fractions is equal to 1, right? So that means x2 is equal to 1 minus x1, which is 1 minus 0 0.4, that is 0 0.6, right? So from this we have 0.6 into ln gamma 2, right? Yeah. So from this we get, what are the values that we get? Uh, so it will be 2 by 3 into 8.314 minus 0.04 into 0.09 by into 1 by 0.6 is equal to ln gamma 2, right? So this is what they needed, right? This is, see, that is a very simple question. So if you do all these calculations, then you will be able to answer, right? So ln gamma 2 will be somewhere around 0.07. Okay. So yeah, this is a very easy question, right? So if you know the relation between excess Gibbs free energy and x1 ln gamma 1 and I mean ln gamma 1 and ln gamma 2, then you will be able to answer this question very easily, right? So yeah. So what you should do is, like, when you get a particular equation, I mean excess Gibbs free energy, you should write all the equations related. So if you don't remember this, I mean, or if you don't know that from this particular equation, you can solve the question. So just write out all the formulas related to excess Gibbs free energy. Okay, and then obviously you will get to know in which equation you have to substitute this one. Okay. Yeah. So let us, I guess you have no doubts in this session, right? So let us get into next session. Yeah. So which one of the following is correct for an ideal gas in a closed system, right? Okay. So this is like, by seeing these options, what is, I mean, which property you should use this, or which is related to this. So do you got any idea? So basically these are Maxwell's equations. Okay. So these are Maxwell's equations, and from these equations uh, will be solving the question. Okay. Yeah. So how we will solve this Maxwell's equations? We solve using fundamental property relations, right? So what are these fundamental property relations? How you can solve this? Yeah, first, and here in options we have differentials with respect to U and H. Means if you use, if you use fundamental property relations for enthalpy and internal energy, then you can solve the questions easily, right? Yeah. So we have, so let us write the fundamental property relations for internal energy. So U is equal to, So how we got this fundamental property for change in internal energy? So if you remember, that's very good. But if you don't remember, you should know the process also, right? So basically, this equation we'll be getting from first law of thermodynamics. So du is equal to dq plus dw, right? So work done dw is given as minus pdv, and yeah, we have we have ds is equal to q reversible by t, right? Dq reversible by t. So this is how we will define entropy of a system, right? So from this for this system we will be calculating, we'll be using this property. Okay, so dq is given as tds, right? So this is how we derive fundamental property relation for internal energy. And we also have h. For h, how you will be solving? So h is given as u plus pv, right? So differentiate this equation. What you'll be getting, dh is equal to du plus pdv plus vdp, right? So substitute this du over here. What you'll be getting? Minus pdv plus tds plus pdv plus vdp, right? So from this we get dh is equal to tds plus vdp. Okay, so these are the two fundamental property relations for internal energy and enthalpy. Okay, so how we'll calculate Maxwell's equations from this? So according to this Maxwell's relation, this fundamental property relations are exact differential equations. So what is the property of exact differential equations? So if a differential equation is of the form f is equal to mdx plus ndy, then dou m by dou y at constant x should be equal to dou n by dou x at constant y. So if they satisfy this relation, then they are exact differential equations. Okay. So write this for du and dh. So what you will be getting? You will get for change in internal energy, it is minus of dou p by dou s at constant v is equal to dou t by dou v at constant s, right? So this is one fundamental property relation, and for dh it is dou t by dou p at constant s is equal to dou v by dou s at constant p. So this is the other fundamental property relation, right? So what are the options that we have? Okay, let us write these equations over here. So what we have, okay, minus dou p by dou s at constant v is equal to dou t by dou v at constant s. So this is one property, and so what is another property? We have dou t by dou p at constant s is equal to dou v by dou s at constant p, right? So yeah, these are the Maxwell's relations. And what we have? Oh, okay. We have gone to the extension, means we have gone to another part. So I'm sorry. We can solve this equation just by knowing this fundamental property relations also. Okay. So yeah, let us write them. Okay. So according to the fundamental property, du is equal to minus pdv plus tds, right? And this equation is for closed system, right? Yeah, for closed system, this is the answer. So first option, dou u by dou v at constant s. So if you maintain a constant s, what you will get? TDS will be 0, right? Which means dou u by dou v at constant s is equal to minus p. So for this option, we have left hand side as minus pv, and here dou u by dou s at constant v. So if you maintain constant v, then it will be 0. Then what will be dou u by dou s at constant p is equal to t, right? So into nR. So from this option we got minus PV is equal to nRT. Okay, and second option, okay, for H, for enthalpy, what is it? The relation regarding, what is the fundamental property relation that we got? Got TDS plus VDP, which means VDP plus TDS, right? Yeah. So do this equation, what we get? Dou H by dou P at constant S. So if you maintain a constant S, what we get? Dou H by dou P at constant S will be V into minus PV. That means minus PV is equal to NR into dou H by dou S at constant P. So if you maintain constant P, it will be T. The same, we got the same equation, minus PV is equal to nRT. Okay, which is not correct, right? So for closed system, what is the ideal gas equation? It is PV is equal to nRT, right? So now option C, what we have, dou U by dou V at constant S. So dou U by dou V at constant S into volume. So dou U by dou V in constant S into volume is minus P V, which is equal to nR into dou Hi dou S at constant P. So dou H, when we maintain a constant P, then dou H by dou S is equal to P. So obviously we get nRT. This is also the wrong option. So finally, fourth option is the correct answer, but let us check whether it is correct or not. Okay. So dou H by dou P at constant S. So if you maintain a constant S, what we get? V. So PV is equal to nR into dou U by dou S at constant V, which is T. So PV is equal to nRT. Yes, congratulations, we got the correct answer. So option D is the correct answer for the above condition, right? So yeah, first of all, read the question and go through the options and check whether it is. So if we use the fundamental property relation, whether we are getting it or not. Okay. So one thing, from the options, how you will know like whether we have to stop till fundamental property relation or whether we have to go through go till Maxwell's equations. So by using Maxwell's equations, we will express in terms of P, S, T and V. Okay. But fundamental property relations we will express using internal energy and enthalpy. Okay. So this is the difference how you will be differentiating this normal questions with, Maxwell's relation with fundamental properties. Okay. So option D is the correct answer, and I guess I'm clear, and yeah, you are so you have, I guess you have no doubts with this question, right? So if you have any doubts, you can post your doubts over here. So not only related to this topic, you can also, you can also post your doubts related regarding thermodynamics or heat transfer. Okay? Yeah. So, so these are like few basic different questions from solution thermodynamics and from Gibbs free energy. Okay, so these are few questions that we have in previous year questions. Okay, so let us solve few more questions. Yeah. Okay, we have matched the following. Okay, so group one is, so in the group one we had minus of dou u by dou v at constant s. So option A, and the second one is dou g by dou p at constant t, and third one is minus of dou g by dou p, so dou t at constant p, and option D is dou u by dou s at constant v. Okay, and group 2 we have, first one is temperature and second one is pressure, and third one is volume, and fourth one is S, which is entropy. Okay, so these are the groups with which you should match the following. Okay, So how you will do this? This is like more similar to previous question only, right? So first of all, you should know what is the fundamental property relations, because should we go till Maxwell's relations? There is no need, right? Because here we are differentiating with respect to this fundamental properties only, right? This molar properties, right? So let us write a fundamental property for internal energy. What it is? It is minus PdV plus TdS, right? Similarly, for dg, it is, so what is for Gibbs free energy? What is the relation? So if you don't know this relation, we have G is equal to H minus Ts, which can be dg is equal to dH minus TdS minus SdT. So dH is, what is dH? We have dH as TdS plus VdP minus TdS minus SdT. So we get dG is equal to VdP minus SdT, right? So yeah, write this equation over here, VdP minus SdT. So these are the fundamental properties for Gibbs free energy and internal energy. So let us differentiate this by maintaining this properties constant. Okay. So for the first one, what we have, dou U by dou V at constant S. So if you maintain constant entropy, what you will get? The second term will be 0, right? So this term will be 0 and you have minus P, and they are asking about minus dou P, which will give pressure, right? So first of A will match with pressure, and yeah, similarly dou G by dou P at constant temperature. So when we have a constant temperature, what happens? dt will be 0, which means dou G by dou P at constant T is equal to V, right? So this will match with volume. Yeah. Similarly, do it for the other options. What will you get? C, minus of dou G by dou T at P. So when we maintain a constant pressure, this first term will become 0, which means minus of minus S, which will give entropy. So third option is this one, and obviously final option will match with first one, right? So let us check whether this is correct or not. So we have dou U by dou S at constant volume. So when we maintain a constant volume, what we get? PdV will become 0 and we get TdS. So it is equal to temperature, right? So we got all the equations, and all of them, whatever we have considered, are correct, right? Yeah. So this is one of the previous year questions that we had in GATE exam. Okay. So if you have any doubts, please post your doubts over here so that I will be able to answer your doubts. Okay. Yeah. So next one. Okay. Okay, again another match the following one question. So we have two groups, group 1 and group 2. Okay, first one is heat and second one is uh, internal energy, and third one is work. So final fourth option is entropy. Okay, so in this we have state function and path function. So this is a very easy question, very easy question. So yeah, we have heat, right? So whether heat depends on a path function, on path followed by the system, or the initial and final states. So heat for heat follows the path, right? Means let us suppose that we are having a reversible process and irreversible process. Okay, so we are having these two paths. So if you consider a differential amount or a very small amount, and if you integrate all this, all the differential elements or all the finite elements, then if this is the first part and if this is the second part, so the area under the whole curve will give you the whole amount of heat absorbed or released by the system. So this is the area for first one. If you but if you want the area when it is following through part 2, then it will be this. Okay, so we have this area left. So for work followed by, the heat that is absorbed or added through first process and second process are different. So there is a difference of this value, right? So because of this, heat is a path function, and similarly work is also a path function. So internal energy is a state function and entropy is also a state function. Okay. So one more important property is when we integrate a differential amount of property, and if this property m is a path function, then it will give a finite value. Okay. So it will give finite values, and then if it gives a finite value, it is called as path function. Okay. So yeah, why it is a path function? Because it will consider the whole area under the graph, right? But if this property is a state function, so what do you mean by state function? So state function is nothing but the difference between the initial and final state. So it doesn't depend on the path followed by the system. So it says that whether it is a initial, whether it is a whether it is a direct step or whether it is an indirect step or whether it is passing through these different paths. It only depends on the initial and final states of the system. Okay, so I guess you are clear with the question, and yeah, so integral dm. Then for a state function, if you integrate a very differential amount as we have done for the path function, then it will give the difference between the initial and final states of the system. Okay. So yeah, these are, see, this state function and path functions are very important because every year definitely you will have one question. Definitely you'll have one question. Okay, so do remember these questions, and yeah, do solve such type of questions. So practice more and practice well. So if you practice well, then you'll be able to answer any type of question, because practice means man perfect, right? So yeah. Uh, I hope you guys are okay with this. You guys enjoyed the session, and yeah, if you have any doubts, please post your doubts. I will be very happy to clear your doubts, and yeah, I'm very uh, eager to clear your doubts. Okay, so in Unacademy app, if you want more such data or more such information about thermodynamics, so install Unacademy app, and in this select gate category and chemical engineering. So if you want more data and more information about this, take a plus subscription. Okay, so take this subscription, and if you use my code Padma 10, then you will be getting a 10% discount. Okay. So let us suppose that we are having 25,000. So actually the price for a 1 year subscription is 25,000. So 10% discount means we will get 2,500 rupees off, and so the remaining only you have to pay the remaining amount. Okay. So yeah, do use my code, and if you like the session, give a big thumbs up, and if you have any doubts, uh, use watch if you have any doubts, please comment in the comment section. So yeah, not only now, anytime, so uh, you can see the session, and yeah, we also have a free platform on an academy app. So I have been taking special classes for numerical, for numericals on thermodynamics. Okay, so if you want to practice more, then go to the Unacademy app and type Tejaswi Nuli. So this is my profile name. Okay, so in gate category, if you type Tejaswi Nuli, all of my courses and all the special class videos and yeah, all the videos you will be able to see. So if you have doubts, so our app has a feature of messaging to educators also. So if you have any doubts, you can message me and you can also comment. So okay, so yeah. So this is how okay, this is how we are solving this type of questions, right? So any doubts guys? See, while solving graphical problems or any other, just follow the steps. Okay, so as see in this graph he mentioned that it is here, it is 2. Okay, it doesn't mean that till here only it is second process. Okay, so means it till here it is the second step. So 1 to 2 is the second step and 2 to 3 is the second, next step. Okay, so yeah, read the questions. So if you don't understand what is the what does the term mean, so read it again and try to solve that again. Okay, so in thermodynamics, first step is you should read the question properly. Okay, so read the question properly, and second one is put the given data, and third one is check all the dimensions. Okay, and fourth one is put the formulas relating the given data. Okay, so if you do these steps, then you will be solving the question very easily. Okay, so first of all you have to remember the formula, and what you have to remember how to put the given data. Okay, so how you will be able to do this? When you practice more number of questions, when you see a lot of questions, then only you will be able to solve any type of question, right? So see, in this question what we had gr by rt and vr by rt. So you should know that this is a residual property, and residual property means difference between volume of real gas and volume of ideal gas, right? So if you know about these terms, then you'll be able to solve questions very easily, right? Yeah. So do follow these steps, and yeah. For chemical engineering guys, I would prefer BK Datta and M Subbu book also. And yeah, so we have test series for an academy in Unacademy app. So go through the test series and give an attempt. So if you like it, take the subscription and do attempt the questions. Okay? Yeah. So I hope you guys are doing well. And if you like the session, share it with your friends. And yeah, they also, if they don't have subscription, ask them to take it, and they can use this code. Okay. So if they use this code, they'll be getting a 10% discount. Okay. So this is it today. Properties of pure substance questions. So what do you mean by properties of pure substance questions? Means what type of question you need to solve. So you want to solve related with fugacities, or so what is the kind of question you want to solve? Okay, so when you are having a cycles, I didn't get you. Properties of few substances means, see, in a cyclic problem, okay, let us consider that this is a cyclic process, okay, and here you want to calculate change in internal energy or change in enthalpy, or what you want to calculate, whether it is work or heat. See, if it is change in internal energy for a cyclic process, it doesn't depend on any property, right? As it is a state function, the initial and final properties of the system are zero. I mean, the same, right? So it depends on initial and final properties. As for a cyclic process, it is the same. Delta U will be zero. Similarly, delta H will also be zero. So while calculating work, we have so while calculating work and heat only, it depends on the properties, right? So just please clarify your, I mean, please put your comment clearly. Means what is the type, what is the, so do one thing, which question you have the doubt, post your doubt, post your doubt as a image, okay? Then I will give you the information about that, okay? Because if you say that how to deal with, right upper corner is not visible. Um, okay, what is not visible? Okay, Shubham. So try to post the image. Then even after completion of the system, I mean of the session, so I will post you the answer. Okay. So I will comment, I will give reply to your comment. Okay. Yeah. So that's a very good session. Have a good day. I mean, the day is ended already. So yeah, have a tight sleep and revise the concepts again and again and practice well. Okay. So yeah, good night, guys.